What is a salt, you may ask? Well, since you asked, a salt is the product of an acid-base reaction. Produces, in the case of a strong acid, strong base, you get a salt and you get water. And so let's go ahead and take a look at a couple of different acid-base reactions. The easiest one is a strong acid, and this is one you're familiar with, which is a hydrochloric acid. And let's choose a nice strong base, something you're also familiar with, sodium hydroxide. That's a strong base. Now, whenever you react a strong acid with a strong base, you're going to get two products. You're going to get some water, so we'll go ahead and we'll have the water out here. This is also known as a double replacement reaction, a neutralization reaction, and if you're really old school, you might call it a metathesis reaction. But it's a reaction where partners are exchanged. So the sodium cation from the strong base is going to get together with the chloride anion from the strong acid and form this very familiar salt, which is sodium chloride. And sodium chloride is nothing more than the table salt that you put on your food. And so this salt, when it comes from a strong acid and a strong base, is neutral. Why? Well, it is a strong electrolyte. It's going to put into solution sodium cation and chloride anion. And both the sodium cation and the chloride anion are spectator ions in this reaction. They're not doing chemistry, and they're not going to react with the water to affect its hydrogen ion concentration, thus changing its pH. So what we can say is, if I have a strong acid, strong base reaction, it produces a neutral salt. Okay? And the same thing would be true if I used a different strong acid like nitric acid, a different strong base like potassium hydroxide or calcium hydroxide. It's going to produce a neutral salt. All right? Now, let's change it up a little bit. Let's use an acid like HF. Hopefully you remember, because I talked about this in both Chem 1 and Chem 2, this is a weak acid, but don't let that fool you. It's a very toxic acid. If you have to work with HF, you generally are very well trained in its usage, and there's usually a facility on where you are working in which you can treat a toxic spill of hydrofluoric acid. Let's mix that with, and we'll change up the strong base a little bit, make it potassium hydroxide, which is a strong base. Once again, this is going to be a neutralization or metathesis reaction. We're going to make some water, and we're going to make a salt. And the salt that we're going to make, though, is going to have potassium and fluoride. And so here you get potassium fluoride. Now this again is a strong electrolyte. It's going to ionize completely, or dissociate completely rather. You get potassium ion floating around, which is a spectator ion in this reaction, and you get fluoride. Now fluoride is the conjugate weak base of its conjugate weak acid, hydrofluoric acid. And fluoride ion is not a happy camper floating around in a solution, an aqueous solution by itself. It's actually going to react with water because it wants to stabilize itself by making the molecule HF. And so the reaction looks like this. Fluoride ion plus H2O in equilibrium. You're going to get the fluoride ion reaching out and doing what we call hydrolysis. More specifically, base hydrolysis of water. It's going to split off a proton from water. So that's base hydrolysis. And when it does that, it's going to make a little bit of HF, the conjugate weak acid. And every time it pulls a proton off water, you get a little bit of hydroxide ion. And that hydroxide ion is going to raise the pH above 7, not a great deal above 7. This is, after all, only a weak base, not a strong base. but you're going to get a basic solution. So if you've got a weak acid reacting with a strong base, the salt that is the result of that reaction will be basic. So weak acid, strong base, basic salt. Weak acid, strong base, basic salt. One more time. Weak acid, strong base, basic salt. Let's try one more. Let's switch it up and let's do NH3. And you might remember that NH3 is ammonia, and ammonia is the principal weak base that we talked about. We're going to mix it with a strong acid, and let's do nitric acid this time, just to switch it up. It is a strong acid. We're reacting a strong acid with a weak base. And so what's going to happen here, there's a nice pair of electrons on that nitrogen. They're going to reach out, grab hydrogen that has been put into solution by this strong electrolyte and strong acid. You're going to get NH4NO3, which is ammonium nitrate, which has a rather legendary history as both a fertilizer and an oxidizing agent in explosives. But that's for another time, another conversation. But in any case, it is a strong electrolyte, so it's going to dissociate, and what you have is NH4+. NH4+, ammonium ion, is the conjugate acid of the weak base NH3. And so if I react a weak base with a strong acid, I get an acidic salt. So a weak base reacted with a strong acid, you get an acidic salt. So you can characterize it. If you have a weak base with a strong acid, you get an acidic salt. So let's go ahead and summarize. If you react a strong acid with a strong base, you get a neutral salt. Strong acid, strong base, neutral salt. All you have to do is look at the cation and the anion of your salt. Does the cation come from a strong base? Does the anion come from a strong acid? If that's the case, the salt is neutral. If you have a weak acid that you're reacting with a strong base, you're going to get a basic salt. Weak acid plus strong base, basic salt. Whatever is strong in this category determines the acidity or basicity of the salt. Since the base is strong and the acid is weak, you get a basic salt. Again, look at the cation. Is the cation from a strong base? Is the anion from a weak acid? If that's the case, the anion from the weak acid will make the solution basic. So weak acid plus strong base, basic salt. And we can go the other way. With a weak base added to, or a strong acid added to a weak base, we get an acidic salt. And we use the example here of ammonia, NH3 plus nitric acid, making ammonium nitrate. And again, if you see ammonium cation in your salt, you're thinking acidic salt. It's kind of a clue. So just try and notice that. All right. We'll do some examples in the next video.